Let's look at another one of these line problems. I want to find the equation of the line that passes through the point negative 2, 6 and is parallel to the line defined by the equation 2x plus 4y equals 16. This equation would define a line, wouldn't it? It would be a straight line. The solutions to this equation form a straight line when we graph them. Well, there's a straight line that passes through this point that would be parallel to that line. I can find, for any point, I can find a line that would be parallel to some other line that was there on the graph. And so I want to find the equation that relates to this point. And it's parallel to the line defined by this equation. Well, our plan of attack has been to use the slope-intercept form, find a value for the slope, take our slope that we've now found and a point, and find our value for b. So from this information, somehow I have to figure out what would be the slope of my line so I would know what to use for m. Well, this concept of parallel is what's going to help me with that. If lines are parallel, the only way that can happen is they would have to have the same slope. If they didn't have the same slope, eventually someplace they would cross, they would intersect. The only way they can be parallel is if they have the same slope. So whatever the slope happens to be for the line defined by this equation, that has to be my slope. That has to be the value I can use for m. Well, this equation is in standard form. If I put it into slope-intercept form, I could read what the slope of this line was, and then I would know the slope of my line. So if I take this equation and put it into slope-intercept form, I'll subtract 2x from both sides first, then divide both sides by 4. Dividing this side by 4, negative 2 divided by 4, I can't do that division and get a whole number answer. I'll just use a fraction. Negative 2/4 is negative 1/2. Plus 16 divided by 4 is 4. I divided both sides of that equation by 4. So the line whose equation is 2x plus 4y equals 16 in standard form is y equals negative 1/2 x plus 4 in slope-intercept form. So the slope of this line would be negative 1/2. If my line is parallel, then my line has to have a slope of negative 1/2. Our m value has to also be negative 1/2. If lines are parallel, the slopes have to be the same. So now I know the slope of my line, so I can put that in for m. I'll put in negative 2 in for x. I'll put in 6 in for y. That will give me an equation that only has b. And I can now solve the equation for b. 6 equals, well, negative times negative is positive. Half of 2 is 1. So 6 equals 1 plus b, so b has to equal 5. So our equation would be y equals negative 1/2 x plus 5. So the equation of the line that's parallel to this one is y equals negative 1/2 x plus 4. Our equation is y equals negative 1/2 x plus 5. And again, this is in slope-intercept form. If we wanted to put it in standard form with integer whole number coefficients, we could bring the x term to the other side, which would give us 1/2 x plus y equals 5. That's what you need to have standard form. The x and y terms have to be on the same side. And if I wanted integer coefficients, I'd multiply by 2 to make whole numbers. 2 times 1/2 x gives me x, plus 2 times y is 2y, equals 2 times 5 is 10. So here's the equation of the line that passes through the point negative 2, 6 and is parallel to the line defined by this equation. Here's the equation in slope-intercept form. Here's the equation in standard form. So I used the fact that parallel lines have the same slope. I found what the slope of this line was. That gave me the slope of my line. I took that slope. I took the y value and the x value of that point, put them into the slope-intercept form of the equation, That enabled me to find B, and I had my equation.